Hello, welcome to CodeFactoryAI. In this video, we continue with our PLC programming course in TIA Portal using the SCL, Structured Control Language. Today, we'll cover an essential topic for any PLC programmer: inputs, outputs, and data types. We'll understand what they are, how they're represented inside the PLC, and how to use them in SCL code to control a real process. And it's not just theory. As I explain, we'll be coding step by step on screen and testing everything in Factory I/O by the end. You'll have a complete project where we'll turn on a lamp using a virtual button. So if you're learning PLC programming, this video is key to understanding how your program connects to the physical world. Let's start by opening the following project file and renaming it to Inputs, Outputs, SCL. If you don't have it, you can find it in the description under the Resources section. This file lets us communicate with Factory I/O to visualize our simulations more realistically. Next, we'll create the basic blocks. In this case, the project already includes the main block. We'll just create a new FB block and name it FB Inputs Outputs, where we'll write our SCL code. The FB Inputs Outputs block will be called from OB1, so its code executes in every PLC cycle. That's all for preparation. Now let's understand how the PLC interprets inputs and outputs. In PLCs, inputs are devices that bring signals from the physical world: buttons, sensors, switches, etc. Outputs are the signals the PLC sends outward: lights, motors, valves. In TIA Portal, inputs are represented by the letter I for input and outputs by Q for output. Each bit can have two states: or true, active signal 0, or false, inactive signal. When the PLC scans the program, it first reads all the inputs, I, executes the logic in the OB1 block, and then updates the outputs, Q. This process happens thousands of times per second, so the PLC is constantly reading, processing, and writing data. That's why understanding how to use I and Q addresses in your code is essential. Now let's go to the FB Inputs Outputs block and define our variables. Here we have three sections: bar input, block inputs, in this case, the button; var output, block outputs, the lamp; var static, internal variables for calculations or control. Each variable has a data type that defines what kind of information it stores. In SCL, data types define how much memory is used and what kind of values a variable can store. BOOL, true or false. The BOOL type can only have two states, true or false. It's used for binary things like buttons, sensors, or relays. In Factory I/O, this corresponds to pressing a virtual button. The PLC receives true and activates an output. INT, integer numbers. The INT type stores whole numbers between 32768 and 32767. We can use it to count cycles, parts, or events. For example, to count how many times a button was pressed or how many products passed a sensor. Real. Decimal numbers. Real represents decimal values, ideal for analog sensors such as temperature, level, or pressure. The PLC uses double precision, so we use real for values that need decimals. The key is knowing when to use each type. BOOL, digital signals. NT, counts or discrete states. Real, analog measurements. Now let's put everything together into a functional program. Let's analyze this part of the program. In var input, we declare the program inputs, in this case bolt and start. a BOOL variable representing a button. When pressed, its value is true. Otherwise, it's false. In var output, we define outputs. Here, lampera, also BOOL, controlling whether the lamp is on or off. Then, in var static, we declare internal variables. Contador, int, starts at 0 and counts button presses, and temperatura, real, starts at 22.5 degrees. This if statement says, if the button is pressed, turn on the lamp and add 1 to the counter. If not, turn off the lamp. This means if the temperature exceeds 25 degrees Celsius, the lamp turns on automatically, even without pressing the button. This kind of mixed logic is very common in automation. For example, to turn on fans, alarms, or warning lights when an analog variable exceeds a limit. This small program combines digital inputs, button, internal variables, counter and temperature, and a digital output, lamp. It shows how a PLC can make logical decisions in real time based on process conditions. Now let's test the program in Factory.io. Open Factory.io, load a simple scene, 1 button and 1 lamp. Connect, button, I0.0 lamp, Q0.0. In TIA portal, assign the variables. Boton start, %I0.0 lampara, %Q0.0. Download the program to the PLC or simulation and watch the result. When the virtual button is pressed, the lamp turns on and the counter increases. If we simulate a temperature higher than 25, the lamp activates automatically. Observe how the values change in real time in the watch table. And that's it? We've completed our module on inputs, outputs, and data types in SCL. Today we learned how the PLC interprets physical signals, how to represent them in SCL, and how to use BOOL, INT, and real data types in a practical program. With this foundation, you can now create smarter programs that combine digital logic, counting, and analog control. In the next video, we'll cover conditional structures and timers to build programs with time and sequence control. If you enjoyed the video, subscribe, leave a like, and turn on the notification bell. I'm CodeFactoryAI, and here, we teach you how to program the future.